right. Good evening, everyone. Kindly asking if someone can confirm whether or not you can hear me just fine.
Yes, we can hear you.
Right, thank you very much. All right. I just wanted to start off with an announcement, I suppose. Sorry about that. I think there was a question regarding the quiz. We had toyed with the possibility of trying to see if we could have quizzes or something. Looking at the fact that there's very little time left and all that, we will only have time to administer a second test, so test number 2, and test number 2, tentatively, we're planning to have this next week. I would like to suggest probably Monday itself. It's going to be a very short test here, and I'm a bit skeptical. Tentatively Monday, which is the 4th here, I'm a bit skeptical because and this is tentative because the sanitation issue at the UNZA is still a bit of a problem. Okay, so either we turn this into a very, very short test or something like that, or we just scrap it off altogether. But nonetheless, tentatively we are scheduling test number 2 to take place on Monday. Okay. Incidentally, actually, maybe to make this slightly more bearable, the other option is we can do this on Sunday. Okay. I can make myself available on Sunday, either at 14 hours, 15 hours, or 16 hours. That's on the 3rd. If you'd want us to have this test on the 4th, then it will have to be at 17:30, right about the time when we have these assessments. We have got to write this test either on the 3rd or the 4th, ideally. So tentatively, and the test is essentially just going to be based on the content that was not covered in the test. So that's the discussion we had on NumPy. Yeah, so it should be a fairly easy test, ideally. I will be in touch later because probably after tomorrow, maybe tomorrow, Wednesday itself, we have a scheduled school postgraduate committee meeting. So in the event that we're explicitly instructed not to administer any more assessments, then we may scrap off the test. But tentatively, either the 3rd or the 4th, I'll ask that you have a discussion as a group, and then you let me know what works best for everybody. So that's that. And then the other announcement I have is regarding the makeup for test number 1. The deferred assessment for test number 1. There are some individuals that were unable to sit for that assessment. I would like to tentatively schedule this for Wednesday at 13 hours. Ideally, I think I probably had hinted at the fact that we would have this test on Tuesday or something, but we have a school postgraduate committee meeting tomorrow, and so I'm tentatively suggesting that we do this on Wednesday. If there are any concerns from individuals that never wrote the first test regarding their availability, you can let me know. And then the other announcement is to do with the exams, obviously. So you'd have probably seen that communication from the Vice Chancellor or something announcing the recess the abrupt recess for the university, and I think somewhere in that memo, the internal memo from the VC was a statement to the effect that the exams would be held between, were rescheduled actually from the 27th all the way up to the 11th of May. So ideally, if you look at the session dates, exams are supposed to be administered beginning today, but because of the issues surrounding the sanitation challenges at the university, of Zambia Great East Road campus, the exams were scheduled to start on the 11th. So they're scheduled to actually run from the 11th of May all the way up to the 22nd of May. Now, the timetable is not yet out, but I suspect one of the outcomes from tomorrow's school postgraduate committee meeting is going to be, I guess, a draft timetable. But if I were you, I would actually maybe attempt to take time off work or something between the 11th and 22nd or something. Although once the timetable is out, you can easily plan for which days you can take time off, because usually with the 4 courses that you have, they're typically staggered, right? So it's likely you probably have two exams in the week of the 11th, and then the other 2 will probably be in the week of the 18th of May or something. So just take note. It's always nice to plan ahead, I guess. All right. Unless if there are any questions, I guess we can continue our discussion. And I don't know if that's a question, but today we're supposed to hopefully transition and yes.
Yeah, maybe about the performance.
Sorry, your audio is a bit muffled. I don't know. There's a bit of background noise there. Hello.
Hello. Okay. Are you getting me now?
Yes, we can get you now.
Okay. Yeah. So I was asking about the test. Saying probably maybe you had gone through. Or what's your advice? What do you think? Yeah, on the performance.
Sorry, advice on the what?
On the test that we wrote.
Oh yeah. So
I'm assuming that
I've not yet gotten around to finalize the grading. I'm hoping I can do this this week. So if we're going to have that test 2 in the week, I mean on Sunday or on Monday, I will bring the scripts.
Okay. All right. Thank you.
Yes. Okay. All right. So we can proceed here. Okay. So today we want to transition to have this discussion centered around one of the most widely used, I guess, data science libraries, Pandas, sometimes referred to as Python Pandas. And then if we have time left, we'll actually quickly look at matplotlib as well. Anyway, so simply put, so-called pandas or Python pandas, I don't know if there's it's an open source. Let me just see if we have, I think we do here. It's an open source Python library for data manipulation and analysis, ideally. If you remember in our inaugural lecture, the one that was tagged as administration and course introduction, we underscored the importance of data, is it, when it comes to data science. Ideally, data science is nothing without data, right? So we toyed around with this notion that data happens to be a very key ingredient to anything to do with data science. Okay, so one of the very first things that you have got to do is, you collect the data, and then once the data is collected, you do some sort of manipulation and analysis so that you extract information, and then using that information you can then derive knowledge or something, right? Well, so it turns out that manipulation of data or analysis of data can be used, with a broad spectrum of tools, and I would like to think that almost everybody who is enrolled into CSC 6741 has probably used a tool like a spreadsheet application like Microsoft Excel, or perhaps is it Google Sheets, or maybe related to a spreadsheet-based application like perhaps LibreOffice Calc, right? Or Open Office Calc, ideally. The idea is the same, right? But it turns out that there are reasons why you may want to use a library like Pandas, Python library like Pandas. First, obviously, if you remember our discussion of so-called data science, right? And I'm sure you've had a discussion in your introduction to data science course here. Typically, when you're working on data science-centric problems, you tend to work with what is called a pipeline, right? Sometimes this pipeline will be called like a machine learning pipeline or an AI pipeline, or perhaps a data mining pipeline. Or in our case, we can refer to this as a data science pipeline. And it turns out that there are a number of operations that you perform in this pipeline. The idea behind the pipeline is simple, really, right? It comprises of a series of operations which will lead you down a path where you derive the end goal, right? The end result, ideally. So like you have an input and the final output. In between, you have a series of operations that you perform. Now, it turns out that when you're working on a data science kind of problem, there are different things that you do. And I believe I may have discussed these things here. Is it, you do things like you collect the data or something, right? You have to clean up the data, so you pre-process the data. At some point, you're going to have to transform the data or something. After you transform the data, maybe you build some sort of model, some inference models to derive knowledge, ideally, right? So call this modeling or something. After you model, you do some kind of evaluation, and then after evaluation, I'll just say we deploy or something. You deploy a solution so that users can actually use whatever data science solution you're working on, right? Now, it turns out that all of these stages here, we can call these stages here, all of these stages ideally would be they would involve some sort of programming, okay? And quite intense programming, by the way, right? And so the idea here is you can take the approach where the things that you're doing in various stages here can involve you utilizing different types of programming languages, right? So maybe when you're collecting data from a data source, let's say you want to analyze conversations surrounding the burial of the late Dr. Edgar Chagwalungu, for instance. You'd say, well, we're going to write some script that will harvest, I don't know if it's comments or something, related to posts associated with Edgar Chagwalungu's burial, right? So you'd have to choose a programming language, and you clean up the data and stuff. But the argument we're trying to make here is that it's usually advantageous when anything to do with programming here at all of these various stages here makes use of the same programming language, right? So once you collect the data and you get to a stage where you're manipulating or analyzing the data, you'd want to use the same language that was used to collect the data, the same language you're going to use to transform the data, to model, to evaluate, and to deploy. In our case, it would be advantageous if we use Python, right? So if we're using Python, we obviously would have to forego this notion that we can use Microsoft Excel to analyze the data. That's one argument, right? But more importantly, it turns out that when you're working on data science-centric problems, many a times you will find yourself working with huge quantities of data, right? Millions of records. And if you've used Excel, you agree with me that it has its limits, is it? I haven't used Excel in a very long time here, but I remember one of the challenges would have interacting with people from sales. When I was working in the telecommunications sector many years ago, I was between 2007 and 2010, was it 2011 or something? One of the challenges here is it becomes really slow, right? And in fact, if you do things like Excel limit or something, if you search, you notice that there's only so much you can do with Excel, right? And I remember what we would do, if you look at these limits here. So you can't go beyond 1,048,570 rows, and also you cannot go beyond 16,384 columns, right? Ideally, So if you're working with complex data, as our colleagues from the telecommunications sector will tell you, this poses a challenge, and a workaround usually would be like, if you're analyzing data in the telco sector, for instance, is you say you're going to summarize the data using, let's say, SQL, right? So you aggregate the information from the database itself, and then the data that you begin to analyze is the data that is already aggregated from the database, ideally, right? Anyway, so there are these challenges that exist, and this is where Python Pandas actually comes in, right? The name, by the way, in case you're wondering where the word pandas comes from here, is derived from the word panel data, right? And the interesting thing about Python Pandas library is it's designed, to work with structured data, right? So any sort of data that has some kind of structure, ideally, is perfect for Python Pandas. And this is a plus for us, right? Because we immediately begin to notice that most of the data that would use in a real-world setting would be structured, right? The things that you extract from your database are already structured, rows and columns, ideally. If you're analyzing data from web services or APIs, application programming interfaces, using formats like JSON, you again begin to notice that this data would already be structured. This also, I guess, cascades to data such as XML formatted data, for instance, right? And it turns out that the structure that one of the primary structures that you tend to work with Pandas, is the Pandas data frame, is organized, or rather data in Pandas is typically organized the way that you'd organize it in a spreadsheet or in a relational database management system. Now, I know there could be some colleagues that are not perhaps very familiar with SQL, structured query language, but certainly everyone here has had a chance to play around with spreadsheets, is it like Excel, for instance. So the data structure is similar to that, where your data is structured in a tabular manner, right? Your observations would be represented as rows, and then the attributes associated with the data that you'd be analyzing using Python Pandas would be organized into columns, ideally, right? Anyway, so it turns out really that Python Pandas is a go-to tool for most time-consuming most of the time consuming parts of data science. So where you are analyzing the data ideally, right? This also includes things like processing of the data, so process of cleaning up the data ideally, and also techniques like exploratory data analysis, right, where you're trying to kind of do a preliminary analysis of the data, maybe to try and identify outliers that may exist in your data set. Try to identify anomalies associated with your data set, so things like missing values, right? So you do what's called exploratory data analysis ideally, and Python Pandas is perfect for that. And you notice that it's quite trivial, quite easy to use, right? Again, just to try and demonstrate this idea of Python Pandas as it relates to something that most of us are used to, which is a spreadsheet application. What we have on the right here, the current slide is a spreadsheet, is it? If you're using Excel, I guess you have a workbook, and the workbook comprises of sheets, right? So what you're seeing here is like a sheet ideally, and maybe what I can do here is go to our usual thing, and then maybe just open up and if I have I'll use this data set. Or actually I can use this. Yeah, dump it here. So that right. So what we are saying here is that given I mean your Python Pandas ideally would enable you to view data in a similar fashion as your spreadsheet application, right? Where you have a sheet, right? It's the sheet name here, right? I'm not using Excel here. I'm using the equivalent of Excel, which is LibreOffice Calc. Works in the same exact manner as Excel and Google Sheets as well. Anyway, so you have your sheet, which you typically would use to represent your data that you're analyzing, and then this data is made up of rows, right? Rows, and these columns, is it? Attributes, these things here, A, B, C, D, ideally. Okay, well, it turns out that so-called Python Pandas organizes data in a similar fashion. So what you're seeing here would be represented in Python Pandas as the equivalent of what you're seeing here would be represented as a data frame. Okay, and within this data frame, in Python Pandas, you may be interested in maybe extracting a slice of the data, right? That slice of data can represent an observation, or perhaps it can represent a particular attribute of the data. Let's say I want to maybe do an analysis, and it's quite common actually, right? I want to do an analysis of gender, right? How do I do an analysis of gender? For this data set, by the way, is for first year students at UNZA here. How would I analyze gender distribution? Well, I can get a slice of gender, is it? So it's column E here. And typically in a spreadsheet application, you do fancy things like, well, I'm going to pivot this data, right? Aggregate it by gender so that I have a sense of the proportion of the two different genders that we have here, right? And then using this information, you can plot or something. Well, you can do more or less the same thing, right? In Python Pandas, you can extract this column called gender, and when you extract this gender column here, you'll be playing around with what's called a series. So it's a series idea, okay? And then you do fancy things here. So anyways, simply put, this entire sheet that you're seeing here would be the equivalent of a data frame. Okay, and then a so-called series is a one-dimensional array object, array-like object ideally, right? Which contains a sequence of values ideally, right? So it typically would be associated with a set of labels, which typically would be called an index ideally. Okay, so you remember our discussion of array-like objects when we're discussing the NumPy library ideally. Okay. Anyways, so it's a series, right? It's 1D, and I don't know if I'm getting ahead of myself here, but maybe we'll look at examples. But maybe we can do this here. Okay, we're getting ahead of ourselves here. Your data frame is a two-dimensional tabular data structure. Okay, it comprises of rows and columns. Okay, and again, a nice way of thinking about this two-dimensional tabular structure is you can view it as a dictionary of series objects, right? So it comprises of different series. Okay. So the columns in your data frame can be of different data types. So depending on the data set that you're working with, the attributes associated with your columns can be numbers, numeric values, they can be text, they can be data, right? They can be categories, nominal attributes, and all those things, right? So what we're saying is these things here, right? This, like student ID here, is a different data type. Student name, different data type, string, is it? Academic year, numeric, right? Date of birth, date-like object, right? Gender, categorical, right? Data type and stuff. So all of these different series or columns can be of different data types. Okay. The first thing to appreciate about Python Pandas before we dive into the gory details of how exactly we get to use Python Pandas is we have got to install it. I know we did this in the inaugural lecture that we had, but a reminder that like all other libraries, Pythonic libraries or Python libraries, the way we install them is one of the ways, recommended ways of installing them is we can use pip, is it? Then we specify the library, and it turns out that Python Pandas is intuitively named. The library itself is intuitively named as Pandas, ideally, right? Incidentally, there is a dedicated website for Python Pandas. So if you just go to pandas.pydata.org, you will have access to documentation and information on and about Python Pandas, including how you can go about installing Python Pandas. So you'll notice that if you go to install Pandas, there's different ways of installing Python Pandas, right? We're not saying that the only way of doing this is to use pip so that you extract or you install the library from PyPy. We see here that we can use Anaconda and all those different things here, right? Anyways, so in our case, we see that for us to install Python Pandas, we just go pip install pandas, right? So come here, and in my case, I have a dedicated environment, if you remember, for this course. So in here, I'll do a pip install pandas. But because I've already installed this, I'll get the message requirement already satisfied, is it? Okay. Anyway, fortunately here, I'm being told here that there's a newer version, so I can update it. I might as well update it anyway, using this command here, just copy paste it. I'm currently using what? I'm currently using, if I do pip list, right, and I check for Python or for pandas, you'll notice that I'm using version 3.0, is it? right? And I'm being told here that there's a new release available. I don't know where this is coming from here. Just going to have to check details about, I don't know where the details of the version are a bit off here. But anyways, I can upgrade this, right? Copy paste. It's a version of PEEP, I think, not Python Pandas. It's just it's a version of PEEP that is 26.0. So Python Pandas is already up to date anyway. This is a new release for PEEP, not Python Pandas. But anyway, so we have that, right? We can use pip install pandas. Then we install this. For us to verify that the library or Python pandas has indeed been installed, we can do an import, right? So we import pandas, and like all packages, no message is good news, is it? So if we do an import pandas, if there's no error that comes out, then everything has worked. A reminder, if we were to mess up the name of the import here, let's say pandas x, for instance, we'll get an error message, is it? In this particular case, module not found error, right? Because there's no module named pandas x, ideally. Okay? Now, putatively, it turns out that when you're working with Python pandas, by convention, you'll notice this actually in most tutorials. You would import it by using the alias PD. So you do an import pandas as PD, right? Pandas, short form for pandas. And so everything you'd be doing would actually use the alias PD dot, right? But a reminder that we know that we can do an import by issuing import pandas, and then what we'd have to do is we'd have to make use of objects, right, attributes and methods in Python pandas by using pandas dot, right? So it'll be pandas dot read instead of pd dot read. But it's always good to go with convention, right? You notice that almost all the examples. I'm going to showcase would be assuming we are importing Python pandas using this statement, import pandas as PD. Okay? Now, one of the very first things you'll probably find yourself using Python pandas for here is you obviously would want to use it to read data, right? Remember, we are saying that this library is primarily used for analysis and manipulation of data. Or before you can analyze or manipulate data, you've got to read that data, right? Open the data file that you're working with. And it turns out that Python pandas has a number of different ways you can leverage to actually read data, right? And this makes sense, right? Because when you're analyzing data, that data or the data source can be from the data can be from various sources, ideally. Okay, you may find yourself maybe analyzing data which is perhaps in a CSV format, so comma separated values format. You may perhaps find yourself analyzing financial records that have been generated by your accounts department, which in all likelihood would be in Excel spreadsheets, ideally, right? In some instances, there are probably real-world scenarios where you may want to analyze data from websites, right? Or true to that, actually, there could be instances where you're analyzing data from an API, and typically your API or web services will be RESTful in such a way that the data format used, increasingly actually these days, we've transitioned from XML, is it? It'll be in JSON format, right? So there's options to read data in all of these different formats. And interesting enough, there's even methods that you can use to read data from SQL. Okay, what I'm going to do in the notebook I'm going to share is I will provide you with examples for how you can read data from SQL. I typically like using SQLite. It's lightweight and all those things here. So you notice here that you can actually analyze data from an SQL database using an SQL query or by reading an SQL table ideally. Okay, so these are the functions that you use, right? The functions that you used are formatted, or the methods will be read underscore. So anything to do with read underscore is what you'd use to read data. So again, I'll import pandas as PD, and then if I use the alias PD dot, and let's type in read here, underbar, you notice that I have all of these different options. So I can read data from clipboard, very, very, very strange way here, right? The clipboard is like, if you copy something, yeah? So let's say you have a data set like this, and I just want to copy the student ID, student name, all the way up to gender here, like this chunk of text here. It's 10 records, I guess. If I copy this, right, what I can do is I can come here and read. I think if I do a read clipboard, I just say var clipboard or something is equal to this. What I have read here, right, is the data that I copied. If you remember, I copied 5 columns here, is it? I copied up to gender. It would be 1, 2, 3, 4, 5, right? And I went all the way up to, I don't know if you can see that I went all the way up to row number 11 here, right? So I have a total of 10 rows right here. So I can copy data from a clipboard. I've never really found myself in a situation where I would have to use this method here, right? But it's there nonetheless, yeah. And then if I have some examples here, but we'll go through these in sequence. You notice here that you can also read data from a CSV file. In most instances, it's probably going to be one of your very common use case scenario, right? It's usually a lot easier to work with CSV files. Most of the problems that I found myself tackling anyway with my students, research students, we will assume that we are working with CSV files. It's usually a lot easier. In fact, even when we're extracting data from web resources, for instance, what we'll do is we would ideally extract the data and then convert it to CSV. Okay, and the idea behind CSV, by the way, similar to what we've done elsewhere. If you want to have a sense of what the function is like, you can use the help built-in function, is it? So in this particular case, pd.read clipboard gives you an idea, right, of what the method is all about and how you can use it. Yeah? Okay. Let me go back to pd.read here, pd.read underbar. There's also CSV, right? So, common use case, like I said. So the idea behind the CSV file here is it's a comma separated values file. But what is interesting about a CSV file is the character you use to separate the records doesn't necessarily have to be a comma, is it? Yeah. I'm going to open the example data set here that we have. You notice when I open this file in a spreadsheet, the spreadsheet is designed in such a way that you can specify, if it automatically is able to read a CSV file, right? It will ask you what separator you're using and all those things. I don't know if you saw this when I was opening this using, don't save here, if I decide to open this file using LibreOffice Calc, which is equivalent of Excel, I get a pop-up, right? This pop-up window which asks me what separator is used, yeah? What separator is used in this CSV file. There's usually this option here, right? There's tab. Common ways of separating data is you can have tab, you can have commas, semicolons and stuff. I prefer to use a pipe symbol. Most of the CSV files I work with. So I'll specify here, say the character I'm using is other and it's a pipe, and the moment I tick this, the spreadsheet application already separates, my columns here, right? Using a pipe symbol. And what it does is it's going into this file, CSV file, and then it checks for these separators here. So it knows that student ID is a separate field from student name, right? So this is a header on top, and then the values here again are separated by using the same character here, which is a pipe symbol idea. Okay, so the way that you read a file like this in Python Pandas is you use the read CSV, right? You use the read CSV method, and the way it works here is it's pd.readCSV. It's a method, so open parenthesis, close parenthesis, and then the very first mandatory parameter you use is the location of this CSV file, because the moment you say read CSV, Python Pandas expects you to specify the file that has this comma separated values data ideally. Okay, you notice here file path, yeah. So you specify the file path, and so what we do here is we say pd.read CSV and we specify where is the location. In my case, the location of this file, is it's in here. So I'll go to my file manager here and then copy this URL. It's in here. This is a complete path. You say it's in here. The file name is this. Copy the file name. Remember, this is the path is a string, so you specify it as a string, and then if I run this without specifying any other parameters, it will assume that the character used to separate the fields is a comma. However, this is not the case. If I enter this, I'll get errors, right? In my case, because the separator is different, I've got to specify this character used, right, explicitly. So there's a sep, right, keyworded parameter that you use. Again, you feed it a string. In this particular case, the separator is a pipe symbol. And when I enter here, I'll be able to get back a Python Pandas data frame. Again, what you're seeing here, right, is the result of this data frame, yeah? The way Python Pandas works is that it will not, by default, it doesn't show you all the columns and all the rows, yeah? It only showcases a snapshot, ideally. So these ellipses here, these 3 dots that you see here, are an indication that in between student ID and final exam are a range of other columns, okay? In between this observation or record with ID 4, right? Indexing of records begins at 0, right? There's these 2 dots here, meaning that there are records in between record with ID 4 and record with ID 452. Okay? At the end here, you'll notice that the result here, right? Verbose output here gives you an idea of the structure of your data frame, is it? Python Pandas is telling me that my data frame has 457 rows and 69 columns, ideally. Okay? It's usually a good idea to, instead of, if I run this like this, it's not going to be very useful, but I have got to assign a variable, is it? So I would say var CSV records or something is equal to this, so that I will then start, this is going to be assigned with whatever is coming out of here, which is this data frame, right? So if I run this variable records, I'll get the same output as before. And this is usually good because from here you can do a whole bunch of things, like we can check the type, is it, using the type built-in function, and we see that this is a pandas data frame. Okay. What else? Besides reading data using CSV, we can also read data, and we use from Excel. Right. So the idea behind reading data from Excel here is best. I don't know if I have an Excel data file. I probably don't have an Excel data data. Let me just see if I can find. Oh, I've closed it, I guess. I'm gonna attempt to open it again here. Oh, I can open it from here. Because the file I have is obviously not in Excel. It's CSV, right? So what I would want to do is I'll open this up again, and then I'll use my spreadsheet application, which is LibreOffice, to convert this into an Excel equivalent file. So I'll use this Excel 2007 to 365 template, right? This, so .xlsx, yeah. And then I'll call this okay, CSC 6741. Yes, is that a question?
Yes, Doc, it's a question.
Yes.
So there are times when, let's say you are loading a CSV file. So you find that you're experiencing the encoding error. So, of course, there's some suggestions that you need to use Latin 1 encoding. I think in the lab that you shared, you used the UTF-8, something like that. So I want to know, when do we use which one? When do we use? Because there are times when you try to use Latin 1, it works, but then you don't know the implication that it comes with.
Well, I mean, yes, sorry.
Yeah, so on the encoding part, that's something I want to understand.
So the idea behind encodings is it's centered around the fact that if you think about the data that we work with, right, they're typically different languages that would be used, right? You know, we take some of these things for granted here, right? The fact that we mostly work with English, is it? But it turns out that there are other languages, yeah, that will have very, very strange characters, ideally. If that makes sense here. So the idea of when to use which one here depends on the type of data that you're working with. There are instances where maybe your data will have very strange characters that may not really be represented in UTF-8, in which case you'd have to obviously find the appropriate encoding to use, ideally, if that makes sense. So it's really centered around the character set of the data you're working with. If that is, I don't know.
Okay, Doc. Thank you so much.
Yeah. So I don't know if people are able to kind of understand what he was saying here. I'm gonna showcase an idea here, right? Also, I guess a nice way of thinking about different encodings here is you look at your keyboard, right? Depending on where you purchase your computer from, you notice that in some instances you will have very, very strange characters on your keyboard. Is it? I don't know if you've seen this. I was literally I was with some acquaintances the other day. They are from Norway, and one of the very first things I noticed is the mobile device. When I was entering my contact on one of these individuals' phones here, is the keyboard had very strange characters, right, that I don't have on my keyboard on the phone here. Okay. Anyways, so it's the idea here is nice way of thinking about these different encodings is relative to the different sort of characters that can be represented in the data that you're working with. Okay, so they will tell you the simplest encoding, actually, simplest encoding that you can probably think of. These are usually taught in your introductory computer systems and computer architecture courses, is ASCII, is it? Which uses 7-bit representation. Now, if you're using 7-bit representation, it turns out that you'd be representing what? About 128 characters. Yeah? And if you think about it, right, you're like, well, if it's 128 characters, if I'm using English, this would probably be, it would be enough, right? Sufficient. Let's just simplify things here. It would be sufficient because the only thing I'm working with here is A, B, C, D, all the way up to Z, right? All right, which is 26. But remember that A, B, C in lowercase is different from A, B, C, all the way up to Z or something like that. So it's 26 times 2, and then you have the symbols. These are not numbers, they're symbols. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9 or something like that. Of course, I mean, we're simplifying things here because the character sets that we work with have evolved, yeah? You now have emojis. Even if you're working with English, you have emojis, you have, on your keyboard, you have symbols like the tilde, you have the @ sign that represent something, right? So if you include all of these different things, you notice that probably ASCII would not necessarily be sufficient, ideally, right? You need something that is slightly more complex, right? Something that something like UTF-8. So typically when you're working with Excel, let's say you have an Excel data, an Excel worksheet like this, and you want to convert this into CSV, right? The face sheet that is visible. The moment I say I want to save this as CSV, is an option typically, yeah? Here, text CSV, and I say save, right? There'll be a pop-up that will come here and ask me, right? First I'll have to confirm, use text CSV format here. And you notice here, one of the very first things this thing is asking me is, what character set do I want to use? The default here, which is UTF-8, is there because when I was configuring my computer for the first time, I told the computer to say, this is the region is, I don't know, is Zambia or something. I'm using British English or US English or something. So it knows internally, say the appropriate character set is this. But you notice there are different options here. Yeah. Some of them are clearly marked like Korean. I don't know what this is. Korean ISO 2022 KR. Right. They're kind of hinting at the fact that if the data set that you're working with is in Korean, for instance, you'd have to use this sort of encoding or character set. Yeah. But typically, you know, things like, in our case, UTF-8, UTF-16 would probably be sufficient, ideally. Anyway, so it's to do with the language usually used in this. Okay. Contrary to popular belief, there are certain languages that have a lot more characters. Okay, a lot more characters that you'd have to work with. Okay. Anyways, so I hope that answers the question. I guess, I don't know.
Yes, Doc, it answers. Thank you so much.
And then I want to showcase like a use case, right? In Excel, typically when you're working with Excel, I've exported this to .xlsx, right? Which is Excel. If I check the file format, if I go to playground here and I check, this is the Excel file, right? This file here. Yeah. If I check the file type here, this thing is telling me that this is a Microsoft Excel 2007 plus, right? File. Yeah. So with this, what I can do is I can say I want to, again, I need to import Python pandas. Don't have to do this multiple times, but because we're trying to demonstrate the read underbar methods, popular ones. You import Python pandas, and then afterwards what you do is you do a pd.read underbar Excel, right? Now, in the simplest form here, what you do is you specify the location of the file. It can be absolute path or relative path. Right? The relative path here is it's relative to the current directory. Usually, when you're writing these programs, right, you probably write or create a notebook in a particular location on your file system. Right? So if it's in here, it can be relative to this. It can be relative to this. Absolute, I don't know if you get absolute versus relative path. Yeah? If you're working with, if you're saying you're on Windows, your absolute path will start from the C drive or D drive or something like this. I think it is this. Christ. So these documents followed by the location, my desktop or something like that, right? And then the file here, file.xslx, I don't know what. So this is what you call an absolute path, is it? A relative path would be if your computer program is in my desktop, the relative path would be relative to where the program is. So you can just say I want to read file.xslx. Or if there's a folder within your directory, you have the folder itself. Okay, so what I'm going to demonstrate here is demonstrate how I will read this. You see the location here? I can use the absolute path from the root. I'm using Linux here. From the root, it will be here. What is the file name? The file name is this Excel file here. Copy, paste it like so. Read Excel, enter. Obviously, I'm getting an error here because I need this package. When you're reading data from Excel, you must have this package installed. So I'm going to come here, and then I'm going to do. Just take note. If you wish to read data from Excel, you need this OpenPy Excel library installed. Right. So pip install that library. I install it. If I come back here, because it's installed, this should work now, right? So I have now read the data in Excel, right? Using the PD underbar read Excel. Now something interesting here, right? A typical Excel file, nobody creates Excel files like this, right? So typically you create this Excel data in such a way that maybe you're pivoting data. So I want to pivot data here. I want to see pivot this by. I want to pivot this in such a way that I get aggregate scores by gender or something, right? Gender, and then I get the final exam scores or something like that. I don't know. Gender, and then maybe I want to spice things up here and say, I want to look at not the sum, but the average score by gender, I guess, in each cohort. I just want to spice things up here. So I have columns and all those things. So you typically have this sort of thing, right? So you say, well, I have the raw data here, but once I analyze the data, preliminary data in Excel, I can pivot it in such a way that it's showing me, right, the different cohorts and, the average scores, right, by gender or something like that. So what else? Well, I can probably try and pivot this in such a way that I want to aggregate this data based on, I guess it's the minor description or something like that, right? So the minor description or something like that. And I want to see the distribution of students count, right? Count for minor description like that. right? Something like so, is it? So that I see the distribution of these program minors. You don't have to understand the data here. But the point here is you notice that a typical Excel file will have this sort of thing. And I can be more here, right? Say, I just want to have a slice of I just want to have a slice of the data so that I see the ages. I want to derive the ages, yeah? I want to have age. There's no age, but there's date of birth. So what I'm going to do here, I'm going to say I'll use this, and I get what is today? I'll get today, and then I'll say today minus this here, the date of birth, right? This thing here. I'm just making things up here. I don't know why this is. I want to derive age here. I don't know why this is. Yeah, this is horrible stuff here. Yeah. Anyways, what I can do here is I can say, it's fine, I'll figure things out here. I can say I want to get, I just want to get this stuff here, right? The first 4 characters. So I'll just say left, hope this works now, left this 4. Text, number, format, numeric. How about if I say text I'm going to get the text, and then this is insane, but I'll also convert this to, I don't use, I use Google thing a lot now. Oh Christ. I use 2026 minus, I use, there we go. I use thing a lot here, right? I use Google Sheets a lot, so some of the functions in here, I don't know. For me to get the age, right? What I'm going to do is I'm going to say 2026 minus this. So I'm going to come here. Just say this. And then I'm going to say 2026 minus, I don't know if it's 2026 minus this. I don't know why this is fading. I guess it's because this has already been converted into something weird here. But it worked before. I'm just going to come here, call this age anyway, it's fine. Delete. We'll fix this later on, okay. Delete. Okay. Year of birth or something like that. Doesn't matter. Nobody cares about this. So anyway, and then we have age, right? So one of the things that I can do here is say, I want to have a slice of this or something. I know why it's taking a while. We shouldn't really be compromising, I mean, making things up. So there are different ages because I don't have them, right? Let's say ages or something. So the idea behind Excel is you typically have a very complex worksheet. Is it workbook? Worksheet. I don't know if it's workbook, worksheet or something. Like this, right? And it turns out that when you read from Excel, by default, it reads the very first sheet here. So observe, if I move these edges to the very beginning here, at the very beginning, and save this, and I come back here and say I want to read this data, for instance, it's going to read the stuff that has the age. Okay. However, if you read up on the help documentation here, pd.read Excel like so, you notice that you can specify the sheet name, is it, as a string, right? So in other words, what you can do is you can say, well, I want to read this, but I want to read the sheet that has, and obviously you'd name this appropriate. I want to read the sheet that has this. So I'll just copy the sheet name here as a string and then feed it here as a string like so. I have to specify the sheet name here. Sheet name, right, is equal to this. And then if I have to save this, I don't know if I have, let me just check here. Excel read. Oh, it says string or thing here, right? Let me just try and see if I can. Sheet name is equal to 1, 2, 3. I don't know why the sheet name is fading ideally. But what I'm doing here is I'm specifying the sheet name by counting, right? The number, right? This is sheet number 1, 2. This is number 3 here. I don't know if this is making sense. I don't know why the string is not working here. Ideally, it should be able to work. Huh? Should be able to work. Sheet name. Let me see if I can copy this. I don't know why this is not working. Maybe not. Very weird that this is not working, right? If this is, I don't know why. I think it should be also if I don't know if I can rename this and if I can rename this. If I can, let me just do this. I'm going to copy this like this. I'm going to do this var Excel data or something is equal to I'll call this Excel records or something is equal to this. Check the type. PD dot, let's see here. Okay, what I'm going to do here is I just want to check I'm just curious, genuinely curious, right? I know why this is not working here. I'll call this var Excel file is equal to pd dot Excel file. And then I'm going to say type. Oops. Okay, it's the Excel file, so file Excel file dot. I'm looking for sheet names. So I don't know if you've seen this, right? It looks like it kind of truncates these things here. So you want to be careful here about sheet names, right? It truncates them, which is why I couldn't find it. So one way of getting around this, if you're working with Excel files, is, and typically in a real world setting, is you don't use these default names. You just call this raw data or something like that, data, and then this is I'll call this pivot program minus, and then I'll call this pivot gender scores or something, and save this, right? So that when I get this again and then I check, I'll have this will work now, right? So if I come here, I'll say Excel records is equal to pd.read. I want to read an Excel file. Well, which Excel file do I want to read? The same file, and I'm using the absolute path. What I can do here is, because I know that it is located in the folder playground, I can use the relative path, forward slash the name of the file, not the absolute path, but the relative path, like so. By default, if I enter this, what do I have? I have data which is in the very first sheet, this one here, this one. But remember, an Excel file will have a lot of sheets like this, right? Right. So what do? I can say I want to read data, but the sheet name is, I'm interested in reading these gender scores here, or these minors, so I'll copy this string here, like so. And so what I've done now is I've explicitly specified that I want to read data, which is in this pivot table here. Right, so anyways, you can read data from, from Excel. If this is making sense, I don't know. And I imagine a lot of you probably will find themselves at work, right? Analyzing, if you're perhaps involved in analyzing data on a very large scale, and you're working with departments that comprise of people that are not technically inclined, in all likelihood, these people will be sending you Excel files, right? Excel sheets, right? Or they will expect you to send data to them in Excel. Send it in Excel and all that crap. I don't know. But anyways, in fact, even the bosses, right? You are sending these reports maybe in an Excel file with data that is aggregated somehow, right? So you probably like insert sheets and stuff like that, right? Not pivot really, but you insert, your charts, and you're sending maybe as the very first worksheet, you're sending, I don't know what this is here, but I like bar plots here, or something like that. You're sending them stuff like this, is it, in Excel, right? So anyways, this is us telling you that you can read data from Excel, right? But you can also read data from HTML and JSON and SQL as well. I'll include examples of how to do this so that you can get an appreciation of this, right? And this is important here because if you're at the beginning stage of analysis of data, where maybe people from sales will just tell you, please send us results on daily sales or something like that, or how much money did we make from prepaid subscribers, how many from prepaid subscribers, how many calls were made and stuff, if you're working in the telecom sector, or if you're in insurance here, how many people have made made subscriptions this month, how much money are we expecting to make. What you'll be doing is you'll be querying some data, right? Because there will be some information system that is used to capture this information, yeah? And then your expectation from sales and marketing or whatever teams you're sending reports to is they'll expect you to send these things in Excel. But what do? You query using SQL, right? Select star from whatever table or something, or select this field and this field, or aggregate and stuff like that. Or you can use Python Pandas, right? To read data from SQL, and then you manipulate the data, and then you send them to Excel. It turns out that there are equivalent methods that will allow you to export, right? when you have records like this here, you can use the .to method, so you can send this to Excel. Once you do analysis here, to Excel, then .xsl, x or something like that. To Excel or something like that. What file is this? XL, something like this. I normally mix up the functions, right? You can export the data. So what I have now is I've created what? A file, this one, which is an Excel file, right? Using Python Pandas. And true to that, if I open it, it will only have what? One sheet, right? Which is this, ideally. I don't know if it's making sense. But anyway, so the key thing here is that you have a series of methods that allow you to read data from Excel, right? I have a series of examples that I'm going to share with you. I use these in almost all my courses. We're going to assume here we're reading data from CSV files, and I'll share these CSV files with you. So there are two data sets. There's this data set that has, these are anonymized, by the way, names and student IDs. These are records for students in a course I taught for many, many years. I haven't taught it in the last 2 years here. But it's quite complex here. It has 69 fields, or columns rather, yeah. But very few records here. Right, so this is it. And because it's a CSV file, for me to read this, right, I would import Python Pandas, and then I create a variable, just say student records is equal to pd.read. It's a CSV file. Where is it? It's in the folder called playground / this is the file name. The separator is the pipe symbol, boom. And when I get this, I will have access to a data frame that represents the records here, right? 457 records, 69 columns, right? Which other data set do I have? I have these records here, yeah? Extracted from the UNZA repository. They extracted from here. Extracted from here, right? So we're extracting records of publications at the UNZA. So again, same location, I'll just say var UNZA records is equal to pd.read CSV file. Path of the file, because it's in a folder called playground, I'll do this / boom. If you're on Windows, the separator is different, right? It's \. Separator is this. By the way, I use this because when you're in Google Colab, it's Linux, right? It's Ubuntu, so you use this same format here. If I was on Windows, the separator would have to be like this. You want to pay particular attention to this, otherwise you get errors here. And if I check this, these are the records I have here, right? Different sort of records. In all these different instances, if I check the type, UNZA records, Pandas data frame. Student records, Pandas data frame. But the number of rows and columns are different. For the UNZA records, I have 8 columns and 1,833 rows, right? Observations. And true to that, if I open this other record here, which is this space thing, I have this sort of structure, right? Identifier column, ingestion date title, creator, subject, type, container ID, and publication date. That's it. not knowing if this is making sense, right? Now, now that we know how to read data, right? Our interest is to understand, is it? Or to start manipulating and analyzing the data, right? But before we start doing that, there are some common commands that will enable you to explore the data that you're working with. These are quite important because many a times you may not have intimate knowledge of the data like I do with the data sets I'm working with. But if you're working with this data yourselves, once I share these things, you have no clue what the data is about, right? So there are a series of attributes that you can access, but also methods, is it? Okay? And we're going to look at some of these here. A few that I've listed here, like, head, we can throw in tail here, I guess, info, describe, shape, for instance, right? You can do a whole range of things here to allow you to explore the data. Now, what the head command does is it shows you by default the first 5 rows in your data set, the very first. So if you look at this, if I do a pandas data frame.head, it will show me this record, this 2, 3, 4, 5, these things here. Okay? Observe. I have a data frame which is var underbar student records, right? This is a data frame. If I want to see the first 5, I'll do dot head, right? Like this. I'll see 1, 2, 3, 4, 5. Right? So 5 rows with all the 69 attributes. I can also see the last 5. And you guessed it, head, knees, and toes or something, right? Shoulders, knees, and toes and stuff. But you can see knees, toes. Tail, actually, not toes. So you can do a var this dot tail, right? To see the last 5 records, right? 1, 2, 3, 4, 5. These are the last 5 records. You also have control over the first records you want to see. So you can run this head, you can overload it by specifying an integer value that specifies the number of rows at the top. So I want to see the first 10. I'll say head 10, right? 1, 2, all the way up to 10, right? The last 10, tail 10. I'll see the last 10 like so. If this is making sense, don't know. There's also the .info method. So it will show you the different data types associated with the columns. Okay? Info about the data frame in essence, right? Right? So all of the 69 I have here, right? All of the 69 records from student data, right? Column 1, student ID, right? Data type string, D type, right? Now and non-now count. How many of all the records, the entries, do not have now entries, now values? I see that all student IDs have values. But if I start going down here, you notice that for the final exam, right, out of the 457 observations or records, only 304 are none now. So it's usually a nice way of trying to have a sense of the data set that you're working with. I can check the info for the UNZA records, .info, yeah, 8 fields or columns, the type, all strings except the last one, which is int64. It's an integer value, right? And then I see here that fields that have now entries here are type and, okay, these, title, creator, subject, type, and stuff, right? If you notice, total number of observations is 1,833. For subject, only 1,809 are none now. So meaning that there are about 24 of them without subject. If this is making sense. Don't know. Maybe. You can also render descriptive statistics for numeric columns, right? So columns that are numbers, when you run the .describe function, by default it will showcase descriptive statistics for all numeric columns, right, or attributes, right? Yeah, count, mean, standard deviation, right, and all those things here. If you notice, maybe useful, maybe not. I don't know. There's more. You can try and get the shape. If you remember the shape from NumPy, right? Same as here. It will show you the number of rows and columns, right? So if I get this and just run, it's not a function, it's just an attribute. So no open close parentheses, right? It's just .shape. It's showing me that, oh, this data frame has 457 rows and 69 columns. How about the UNZA records.shape? Oh, it's 1,803 records with 8 columns, ideally, right? And you guessed it right? The type of this is what you can literally see. It's a tuple, right? Or a tuple, depending on where you're coming from. Yeah, if this is making sense. There's more things here. You know, you can run columns, right? Dot columns, the columns attribute. So I'll get this student dot columns. It will list. It will give you out. Type here. It will showcase the column names, right? The type is of Pandas index here. But these are the column names associated with the data frame you're working with. All the columns listed. I usually use dot columns to have a sense of whether have I imported the data correctly? Do I have the same number of attributes as my data set? I see the names or something like that. Sometimes this gives you an idea of what you can rename, ideally, if it is making sense. Okay, so quite a number of things here, but surprise, you can use dir as well. You say, what sort of operations and attributes can I run, right, in Python for this data frame? Yeah, some of these things I haven't even used myself. There are quite a number of things here, right? To string, you know, to Excel, to dictionary and stuff like that. So it's quite a bit available for you to use. You notice it's quite interesting, right? Observe. You can do a lot of things here. Like I have 1,803 records, right? But wait a minute. What columns do I have? These. We'll talk about this just now. And then I'll say, well, what I want to do is I want to group. I want to group these things by excuse me, by type. Okay, how do I know this? Well, I know that var underbar records type has things like this, other thesis and stuff. I know the data set here. I'll cast this to a set because the set has unique entries. And I see that, oh, there's a restricted set of types. So I want to gain a sense of the quantities associated with these different types. I can do this by using a group by function, right? I'll come here, group by type. I'll just get the size here, like so. Right, so it tells me here there's 67 articles, you know, 1,420 theses and dissertations and stuff, but I don't know. Anyways, so there's that, right? So these are some commands that you would use to kind of gain a sense of the data that you're working with, right? The data frame that you're working with. Okay, I don't know if any thoughts so far. Okay. Can you still hear me? Okay,
Yes, Leo.
Yes, Doc.
Okay, thank you very much. I don't know what's happening. I can't see myself on my mobile device. It's a bit weird here, but strange here. Anyhow, so there's exploration, yeah? Well, it turns out that there's ways of analyzing the data. Remember, our goal here is to manipulate the data and to be able to analyze the data, right? That's why we're using Python Pandas, right? So in terms of selecting data and filtering data, you're doing that because you're wanting to ask certain questions, right? So for instance, it would be like, can you list of this Python Pandas data frame, right? Which has a lot of columns, 69. Right? Can you export can you show me the student IDs and student names for the data set? Okay, well, it's like dot columns, right? Student ID and student name, right? So I can get a slice of this. I will get a slice and you say this, right? Like this. And then I've just extracted 2 columns, right? A slice, right? Student ID and student name. Okay? Can you, I guess I'm getting ahead of myself here, but can you extract, I don't know if it's filtering or something. So you can select, right? You can filter. You can filter specific rows, right? I want you to extract students, student IDs and student names that are females. Okay, that are females. So there are conditions. Remember conditions that we looked at? We can filter these conditions here, right? So there are ways in which you can filter specific rows, right? Or ways of filtering observations or rows that conform to a particular condition. So in the example here, I want to get females, right? I know that the female, the attribute that tells me whether something is female or male is gender, right? And I'll have to have a sense of what values do I have in here. They are these. Okay? What data type? It's a string. If it's a string, I can use a condition, right? I can say I want to get this where the gender column is equal to, by the way, it's a string here, and I can cast this to a set so that I get unique entries. There's just F and M. F for female, M for male, right? So I'll say, okay, if there are females and males, I just want females, right? I want females, right? Double equal sign is equal to, because this is a string, uppercase F. And when I enter this, right, when I have this is going to return a Boolean value, true or false. Remember, Boolean is true or false, right? So it will show me where there's true here, it means this condition has been satisfied. This is female, male, 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 female, male, male, female, male, female, right? So for me to extract those that are female, student IDs and I guess and student names, including the gender, what I'll do is I'll come here and I'll include gender, right? Like this, right? These are all female, male, male, right? So what I can do here is I can say, I want to come here, this is my condition. The condition comes in square brackets right after I specify the data frame. This is my condition. And what I want is, I just want to extract, I want to extract these. Like so, right? So all of these are female, right? And there are 147 females, yeah? If you notice this, I don't know if it's making sense here, but what is crucial here is that I'm specifying a condition, is it? I've got to kind of think about the condition, you know, looking at the data type and stuff. Gender has male or female. How do I specify the condition? Well, the condition is specified by me specifying the data frame, right? And the operation. I want to check if the result of this is female. This would be true or false, right? If it's true or false, then I use this as my condition. The way you specify a condition is you use a square bracket, is it? You get the data frame, boom, square bracket, condition in here, right? What is my condition? This is my condition, boom, right? Is what I have here. If I run this already, it's going to return all columns, right? All of them here, 69 of them that conform. There's still 147 rows, but all of the 69 columns here, these, all of these things here. But I may not be interested in all of these things, right? Which is why at the end here, I'm specifying to say I want female IDs. I want female names, right? This is making sense, I don't know. I want final exam scores for all females, right? These are them, yeah? And I'm picking these things from here. I already know the data structure here. I created this data structure, so I know it, and, you know, yes, there's a question.
Yes, Doc. What's the difference if we're calling these columns using a dot formula?
Well,
In
so
Yeah.
there's no difference at all. It's just that it's an alternative way of evoking this formula. What he's saying is that if you notice, if I have student ID, you notice how I have these different columns, right? If I want to get gender, I was doing this. I was using the square bracket and then string gender like so, right? I get these values. Another way of doing this is I can do a dot gender, right? I get the same result. This is what you're asking, right? This dot.
Yes, yes.
Yeah, it's just an alternative way of referring to a column. Now, I want to say something here. The problem with using a dot here is that sometimes you may not have control over the columns, the way they were created. The dot only works best here if you rename these columns, right? So what I mean here is that, I don't know if I still have the Excel. What records? Excel records. Have you noticed something here? Observe. If I attempt to say var student records dot, what I have at the very top here are going to be dot the names, right? These are names of columns, right? Academic year and stuff. But observe, in a real world setting, Excel records, in a real world setting, right? Some column names will be strings like this with spaces and stuff, right? You can't use the dot operator here with count, right? You can't say count here. It's not going to work. But you can do it with minor description. Why? Because minor description has no special characters like spaces and stuff. You understand this? So I want to be very careful about this. It's one of the reasons why I personally prefer to use the square. The notation where you're specifying this by using squares to extract what you want. It works. The only way this would work is you'd say you rename, right? There is such a thing as a rename function. So you rename this, right? You rename this column here to something else. I don't know if I've forgotten how to rename here. It has to be rename columns. There we go. So dot rename columns. You're using a dictionary, right? So the only way this would work is if I come here and I say dot rename columns. I'm going to say this is going to be renamed to, I want to rename this to count, what is that now? Student ID, like this. What the, sorry about that. Help is not supposed to be there. La, 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 la. rename. Mixed up I've mixed up the way renaming here. I'm just trying to figure out. Let me see here, rename. This looks like it's, I don't know if I need to specify the access or something. Rename. I've not memorized this. Looks okay though. I don't know if I'm gonna copy this here.
It's a key value pair.
A key value pair. Thank you very much. Yeah, full colon. Beautiful. And this is I was using a comma here. This is a dictionary, so key value. Thank you very much. And then I have to do an in place here. I guess it's going to true or something like that. So that now when I check these records, this now I can do a dot here. Dot the count to be there, right? So that's a difference. It's just like an alternative way of doing this. And that you'll find that the examples I'm using here are not cast in stone. There's obviously different ways of accomplishing the same thing, right? It's not like the things I'm showcasing here, the only ways of doing this. You know, so depending on the sort of tutorial that you are working with, you'll find alternative ways of doing this. Anyhow, it's neither here nor there, I guess. So this is how you filter, right? Now, you know, when you are filtering these things, right? If you remember what we were doing when we were filtering this, I don't know if I have examples. I will add more examples on filtering this, right? You know, when you have a Pandas data frame, right, like this, there's a lot of records. You wouldn't really say, well, I just want to get records that have where the gender, I just want to extract females, right, like this. No, this is not what you do. What you do is you'd say, I want females. Okay, observe, I have this, right? I have 457 records. I want to just look at female students that passed, okay, the final exam. Now, passing the final exam here is like 45, yeah? So, you know, put it at 45. That's a C at the University of Zambia for undergraduate students. 50 is a C for postgraduate students. So what I'll do then is I'll say, I want to get records where the final examination is going to be greater or equal to 45. Boom. So it's showing me that the first record is greater or equal to 45. Not the second record, fail, right? If this is making sense here. Now, the question to ask is, how many passed? These are the ones that passed here. There are 185. So the question is, how many of these 185 that passed are females? Well, I'll have to compound them, right? Because I have a condition for passing. I also have the condition for gender, right? Which is equal to female. So what I can do here is I can compound them. How do I compound them? Well, I'm just going to say I want females and they should have passed. Boom. They should have passed. right? So there are 58. So you see here, I have 58 females. And this is interesting, right? The way you ask questions, what proportion of females passed and stuff? Well, I mean, well, these are the students, they're 58. How many are they? Well, they're 58, obviously. And how many females do I have here? Well, female students are here. There are 147. So what is the proportion? Well, the proportion is those that passed out of all females times 100, right? So it's like 39.5 females passed. It's like, okay, the pass rate is 39.5. I guess it's 39%. Well, what's the pass rate for males? I'm just changing this to like M here, right? Because M, but it's going to match with the other M here. So it's a proportion of males that passed. It's like this, 40%. Not 41%, I guess, rounding off. Not too much, too far-fetched or something. So it's like pass rate for females is 39%. Pass rate for males, 40%. What is overall pass rate? Well, overall pass rate is, I'm just going to count those that passed. Christ. Those that passed, these passed. How many passed? These. Against the entire data set, len this. Divide. Times 100 or something. So, the pass rate is 40%. Right? That's overall pass rate. The pass rate for females, 39%. Pass rate for males, 41%. And stuff like that. So it's like an example of how you'd be asking questions in Python Pandas. I guess slightly more complex or something like that. I guess, I don't know if this is making sense. Well, so for conditions, right? You can also have weird conditions here where you're saying, okay, we know that our data set has quizzes and exams. I want to find out females that passed test 1 or test 2. So it can be a failure in test 1, but if they pass for test 2, return them. What do you do? Or, right? Use the or operator. You remember there were conditions there. Or, and, not, and stuff like that, right? If this is making sense. Right? I don't know if it's making sense.
Sorry, Doc.
Yes.
So are we able to use the... Okay, I was thinking in terms of using the group by. Are we able to use the group by to achieve the same result?
Achieve the same result as in getting...
The 39% of the females that passed.
Well, I guess so. I
Using
mean, so,
the area.
yeah, so what you can do is, we know that this is gender, so you can do something like a group by. Group by, maybe a bit tricky here, right? Maybe a bit tricky because there are conditions here. I have to check group by, there are conditions here. So what I can, well, what you can do is, you can only do this by, if you're saying group by gender, and then you say dot size or something. So I want to get the count of females and males, right? And then you have a way of, what is this? Is this a data frame? What is this? Series. If this is a series, then the only way you can do this, again, turn this into a list here. The only way you'd use this is maybe by extracting the true number of students, right? So you can say, well, I know that this thing here, females, it says females here. I know that this will give me number of females, right? And Compounding this would show me females that pass the exam. var student records greater or equal to 45, I guess. Final examination, like so. So this gives me a count of females that passed. But instead of doing another count here, I can say divide by, you guessed it, come on, this divided by this, right? Times 100 or something. If this is making sense, I don't know if this is making sense here. Have I answered your question?
Yes, you have answered it. Thank you.
Yeah, I mean, there should be, if you look at the group by function, I mean, there should be a way, there's no really, there may not necessarily be, I'm trying to see here, there may not necessarily be, yeah, because when you group, when you're grouping, you're aggregating, right? You've already aggregated, but yeah, so it'd be a bit tricky here. By the way, the group by function is like if you've done SQL, right? It's your select blah 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 count, and then you have count or something, or sum or average, and then you have from whatever group by or something, right? And then when you have the halving, right? This condition is looking at applying the condition to your aggregate. In fact, forget about this if you haven't done SQL already. If you've pivoted data before, it's like this, right? I have a pivot here. You know that applying conditions in a pivot table, right? Okay, this is, I guess, slightly different. In a pivot table, you can apply conditions where the final exam here has got to be of a certain value or something like that, right? I guess you can apply the condition. But the idea is you only the filtering can only be done at the stage when you've already kind of aggregated. So if I'm aggregating I'm getting the average scores for the minors, I can filter, right? I can filter. When I do a group by, I can filter by using the lambda function. I use the filter function. I use the anonymous function, lambda function, to specify, to say I only want to get maybe average scores that are a pass or something like that, if this makes sense. I don't know if this is kind of making sense here. Yeah, and by the way, the and stuff, observe. I'm gonna go back here. Remember when I was saying we want to get how many females have passed? 58. This ampersand, this ampersand, I was expecting some of you guys to ask, but where is that thing coming from here? Well, boom, right? I mean, you'd have to do a couple of fancy things here. I don't know if know why this. I wanted to explain something. You know, the reason why this doesn't work here. Let me see here. Don't know if this is expecting me to, not this, I don't know if it's expecting me to do this or something. Yeah, I would have to look up. There's an explanation why the actual. Remember, we have the and keyword and not. I don't know if you remember that, right? When we're did we? I think we did this, right? When we're looking at Boolean operators, right? The truth table. I don't know if you remember our discussion of and versus and is it truth and truth, truth and false, false and true, the truth table. I don't know if you remember that really. What we were doing was what we were doing was we were using the and operators, right? It turns out that you'd have to explicitly tell Python pandas that you want the true value ideally, right? This is why I'm getting the ambiguous. Is it ambiguous? Ambiguous result here, and you have to specify here. Say you want. I don't know why this is not fading here. I mean, why this is fading. Dot O. I want all results here. Should work though. Dot O. I don't know why this is. I don't know if it wants me to do this or something. Or maybe it wants me to do this. I don't know. Like this. I don't know if I need to wrap this. I've really forgotten. I've literally forgotten. I will check this to try and explain exactly how you can. So it turns out what works best ideally is if you don't really use you don't really use the and keywords ideally. Okay, you have got to use the you use equivalent operators, right? So and is this, right? And then or is this, and then not is this. Okay, if that is making sense. So in other words, like if you wanted to go back here, I'll go back here. I have a condition of these are all students that so these are all female students that passed. If I want those female students, these are female students that passed, right? The opposite, right, is this 127. If this is making sense, so not, right? I want to get the opposite negation of this ideally. If this is making sense here. So anyways, you want to just take note of the fact that these operate on scalar values, right? Individual values. Whereas this what we're doing here is we're doing this, it's like row by row, right? We have like, we have what? We have 457. So we are applying, for us to apply these conditions to each and every one of these, if we use the and sign here, what's going to happen is some results are going to be false, some results are going to be true. And so Python finds it a bit confusing to distinguish between those different multiple results. And the only way you can do it row by row, comparison row by row here, is you use and, or, and not. Sorry, not, which is a tilde. If this is making sense. Anyways, I hope this is making sense. I'm trying to see if there's another something else that we can use. Well, so the way you also ask questions is you want to select, right, specific records, you know. Like I want to find the very first record. Well, there's iloc, right? Right, the position using the index. I want to get the record at index 1. This is it. Yeah, yes, just a single record. Now, one thing you have to remember here is, of course, surprise, surprise, is a series, right? I've extracted a complete record. It's like this. I've gone out there and I've extracted the entire thing that is in yellow, all of the things here, right? You can extract the record itself, right? iloc. Sometimes you can take advantage of observe. If I get iloc, there are these ellipses telling me that there are other, what do you call this? This won't work really. But there are other fields here because there are 69 fields here. There are other fields that exist here. This usually works best. You can transpose, right? It usually works best if you use maybe say head like this. I want 2 records or just 1 record for head. But I want to be able to see some of the columns here. I can transpose this, right? .t, right? The t attribute. So that I kind of flip the columns and they become rows like this. You understand this? Incidentally, if I say I want to get head 1, it's the same as me saying I want to get iloc at position 0. Right? It's the same thing. This is exactly the same as this. I don't know if you can see this. Head 1, right? This is Elijah Temba Mahomani or something. It's the same as this. Elijah Temba Mahomani. Female. Who passed? Or something like that. Anyways, I don't know if this is kind of making sense here. I guess, I don't know. Well, so there are some interesting things we can do. I thought now would be a nice way of trying to link this to some of the things we've discussed, right? Remember where I was saying want to check which students have passed and failed or something, and we're using all those conditions, right? Greater than and stuff. Well, another option would be we say we're going to create a function called pass or grade status. Okay, not grade status. Let's say the score status, and I want to get the score here. And what I want to do is I want to check if the score is greater or equal to 45. You return true. Else return false. And then what I can do here is I can go to this and I can check this, verify it, right? Score, what is 0? Fail. What is, and if you want, I could have said pass or fail here, by the way. Instead of doing this, I could have come here and said if this is equal to that, return pass, else return fail or something. So I have a function, right? A function that kind of tells me if a score is fail, pass, fail, pass, right? So what can I do? Well, what I can do is I can get all of the things that are scores here, right? I have final examination, right? 54, 33 and stuff is out of 100. What I can do is I can use the apply function. What the apply function does, enables you to apply a predefined function, right? In this particular case, it's showing me for each score, right? For each score, show me whether it's a pass or a fail. So the first score is a pass. This is a fail. NA, not a number here, means the value is missing, right? It's now, and our heuristic is wrong here because anyway, if it's missing, then it's a fail, right? They didn't write the test or something, but we can do better in terms of defining the function. So this is another way of kind of solving the same problem, trying to figure out who passed, who failed, right? You write a function, if this is making sense. And incidentally, there are actually other ways of final examination. There are other things that you can do, right? Because data will be messy, missing values. You need to replace values and stuff. They are predefined functions, right? So I can use the isNA function, which checks. It will tell me if this does not have a value to say true. If it has a value, it's false. So expect false true for first true, right? False true. It's a nice way of checking, right? Which values are now, right? Yeah. Or excluding those values that are now, right? So you can use isNA. You can also use things like drop NA. I believe it is, right? So what the thing is going to do is it's going to traverse through all the records, right? 457 or whatever, and then it will check for all of those that are now, meaning they didn't sit for the exam, and so we don't want to do our analysis based on now entries, because somebody didn't write the exam and you include them in the analysis. Sure, you're going to come up with something like, oh, the pass rate is like 40%. This is terrible. Well, your analysis included people who did not write the exam. So what you do is you can do a drop NA or something, and then you do your analysis based on this. You understand this? I don't know if you understand this, but we have to be careful here. In place is equal to true is usually better, right? So that this now, I have only, I would have to drop NA. I don't want to drop NA here. This is horrible here. If I drop NA for everything, I'm going to lose everything, right? If this is making sense. If I wanted to do an analysis of just the final examination, right? I can say drop NA here, right? So that the analysis will be based on 304 records, and not the entire 457 records or something, is what I'm trying to say. So drop NA, you can use your help built-in function to check these things here. There's also a function that you can use to check if something has a missing value. So I want to check if which records have a missing entry for final exam, so that I don't include them in my analysis. And if you're following through, right, this condition, right, tells me which records are nows, right? It will tell me which ones are now and stuff like that. So what I can do is, for me to just get things that are not now, I can use this condition, right? I flip them, the tilde. And the reason I'm doing this is, I'm going to roll back here so that I showcase what I'm trying to say. I want to get the percentage of students, female students or male students, whatever, that passed or failed. Females. I want to go back here. Len. I want to go back to the students that passed and failed or something like that. Nope. This. If you remember, we said the proportion of female students that passed, right, is this, right? But this is flawed. Why? Because we are also counting those that didn't write the exam. How can we include those that wrote the exam? In here, we're saying get all students' records that are female and wrote the exam. So I'm going to get this. The unwrote exam here must have this. And then here again, I want to get female students who passed and wrote the exam. And if I run this now, beautiful. This is actually a true representation, right? Pass rate for females is 56%, 57% actually. Because now I'm not polluting this analysis by kind of like including things that, entries that did not pass. How about males, right? I'll come here and male, all the way here, all the way up to here again, male, like so, right? So the pass rate for females is like 57%, the pass rate for males is 63%. Okay, of course, there are other things at play, the fact that there's disproportionate representation of males against females and all those things, right? If you're looking for an explanation of why is the female and male pass rate vastly different and stuff like that, I don't know if this is kind of making sense, but that's neither here nor there. Yeah, I don't know if there are any questions so far, right? Pretty straightforward things here. We are slicing. You have to remember how to slice and dice. So somebody comes to you and they tell you, there's a student, right? I want to check the results for Elijah Temba Mahoney or something. Okay? Now you wouldn't do this in real world setting, right? Because we use same names here. So I say, well, I'm looking for a candidate I want to get results, quizzes, exams, and exam scores for a student who has a student name of this. This is a condition. I want to extract the records. Where are the records? All the records. Well, but it's not really all the records per se, but I want to get the test and the exam scores and the quizzes, right? Yeah, so this is what you would do here. Yeah, I've extracted just the results for Elijah Temple or something. Now, if Elijah Temple is a name that is common, like Jackson Piri, what would happen is, the rows that would be returned will match that name, which is why you want to use a unique key, like student ID, something that you know is only going to be specific to one student in this particular case. I don't know if this is making sense. Pretty interesting stuff here. I'm gonna pause here, right? And well, maybe not we pause, not yet, but just to mention that there are additional common functions, right? What we've looked at, mostly things that you use to read data, to manipulate data, and to analyze data. But it turns out that there are other things that you can do, right? Like you may be interested in exporting data, for instance. So there are these two functions, two underbar functions. You can, just like you can read from certain things, if you have the result like this, maybe they're asking you to say, please send us results for this student quickly. It's in Excel now. I'm just going to say to observe. What type is this? Pandas data frame. So I'm going to say to, I want to send this to Excel. And then I'm going to say, I'm sending this report, results for, in full colon, name, right? Excel is what? What's the, XLS, I always forget the thing, it has too much, the extension. I want to create a file called this. I'll just call this results ICT 1110 for this student. Boom. Right? And then you just find attached or something like that. You'll find it in here. There we go. So this will have like results for this Elijah, right? If this is making sense here. I just extracted stuff. Boom. You find attached results for Elijah. Now, you probably wouldn't want to send these other fields, so you'd say, well, I want to return just quizzes up to exams, right? If I want to return only quizzes up to exams, you guessed it. What you can do is you can actually say, I want to observe, colleagues. I want to return exam. Wow. I want to return just quizzes, exams. I know they're towards the end. Yeah, I just want to return these things here. Okay, that's fine. We understand. What we do, we come here and then we say, instead of just exporting everything, I want to export this. Oops. Ah, Christ. I want to export this new lines, right? I want to export this. This is the way my terminal works. So I want to export this. Just the results. Boom. Not just the results, but also the student ID and the name and all that stuff. So I'll come here and say, I want to return student ID, student name and quizzes. Boom. If I go here and check this, but where is it now? If I come here and I check the results here, it will not have all those. Oh wow. It will not have all those. It now has. I'm going to close this. I don't know if it wrote to it because it was open or something. Yeah, if you notice now, I only have quizzes and exams and stuff like that. What else? Well, you can actually index these by observe. You can index these by specifying, right? I think I can do index 0, no? No, I can't. I want let's see here. I want there's a way of slicing, right? I wanted to showcase a way of slicing. If you notice, I'm attempting to slice here, you know, but there should be a way of slicing columns in Python Pandas. What I'm slicing here, if I say full column here, I'm slicing. If I say to 1, right? I'm just getting records from 0 to 1, excluding 1, which is just the first record here. If this is making sense. I don't know if this is making sense. If I say 1 to 2, I'm getting 0 and 1. So 0 and 1, right? It should be, let me see here. Yeah, it's loc, right? Location. So what I can do here is I can say I want to, no, but anyway, I want to get, yeah, it's location. So I want to get, first one is rows. If you remember, this is kind of, I want to get 0 to 1, right? 0 to 1, row 0 to 1, and then in this particular case, I want to also get 0 to 1. Ooh. 0 to 1. I don't know why this is not working. Or is it iloc? Okay, I guess it's iloc, not loc, right? So loc only works in indices. So with iloc, I can kind of specify. I can specify from what index I want to extract this thing. So I want to extract just the first record, but I want specific columns. So what I can do here is I can come here, right, and say, well, what is the index of quiz 1? This is where I want to begin. And you guess it right, you can do things like list and then you say count index, I think. Is it? Don't know. 43, right? So what I can do is I can say, I want to start extracting things. I just want the first student like this. But what I want to do is I want to get everything from quiz 1. Boom. So now I have quiz 1 all the way up to final exam. If this is making sense, I'll even transpose them, right? Like so. I'm just saying that when you have a very large kind of data frame that you're working with, copying and pasting the fields may be a bit, kind of a bit of an issue. So what you can do is you can slice, right? You can slice the indices or something, right? So there's this option, right, where you're using loc, or you can say I am just okay with specifying them by name. So I want student ID, I want student name, or something like that, right? And I also want the final exam like this, right? I don't know if this is making sense. Okay, so anyway, the key thing here is that there are common methods, right? Again, I showcased you can rename, you can group by, a whole series of things. Now, I think you're doing NLP next term. these things, you see them in action, right? When you see real world examples here. But I want to showcase something here, right? I'll showcase the Pandas kind of thing for you to go through, a notebook, which will have easy to follow examples and some example problem sets. But I want to showcase something that I was literally working on today, I guess. I've been working on it over the weekend. I'm trying to kind of make changes to something here. I have, I don't know if I have, no, I don't have to showcase this, right? So I'm writing a paper, right? A paper, by the way, is supposed to be submitted somewhere. It's been pending for a very long time here. This paper, right? This paper is actually linked to this data set, a student data set here. Now, the reason I'm showcasing this is that for us to get to a stage where we're doing this, right? It's like you're analyzing data and stuff. We have a whole bunch of fancy things here, right? Graphs like this, like this, density plots, tables and stuff. It turns out all of these things here are a direct result of this notebook. And in this notebook, right? In this notebook, and I'm glad I was actually working on this over the weekend here. A nice way of trying to demonstrate a real world example, I guess. I don't know, but so if you look at this, right, it's like I'm assembling a very lengthy notebook here, right? It's quite complex. It's marked down and stuff, but I'm reading data from my drive, right? A CSV file, a series of CSV files, and then once I do this, I do the installations, the imports, and then I do the things I was talking about where I'm inspecting the data set, right? Dot head and stuff, right? I'm generating plots, doing a whole bunch of things. I guess the point I'm trying to showcase, demonstrate to you is that you wouldn't really be using Python Pandas by just running these simple things from demonstrating, right? You're interested in summarizing data, right? Summarizing scores. You're interested in generating complex plots like this, right? After you summarize this data, you do some sophisticated analyses, like you build models and stuff, and at some point, but where is that? I would have to rerun this, I guess. There'll be some plots that you'd have generated and all that, right? Is the point I was trying to put across. I guess, I don't know. But the idea is the same. The key is, this is the staging area. Python Pandas is like your staging area where you're reading the data and then you start analyzing the data. As part of you're analyzing the data, but you're doing all sorts of other different things, right? In some instances, you're training models by using data from your Pandas data frame. You're plotting graphs using data from your Pandas data frame, right? You're exporting data, you're generating graphs using data in your Pandas data frame, and all those things. I don't know. This thing is expecting me. I have to rerun it all the time. So I shall share examples. Happy to share maybe. This may be confusing. If I could probably share a notebook that we're using to assemble this paper as an example. I don't know. All right. Colleagues, I wanted to find out if there are any thoughts or questions. There's a last remaining piece. I would want us to just talk about matplotlib, how to graph, and we just need maybe an hour and a half for this discussion, and then we are done, because we are tentatively planning to have test 2 on NumPy, just NumPy, on Monday. And in fact, I think we can do NumPy and Python Pandas so that we are forced to study for the exam as well. So the test will have NumPy and Python Pandas only, right? Not too difficult, easy stuff. So because we're planning to write this on Monday next week, my proposal is that we have our last class now, the last remaining bit. Our discussion of this course will be incomplete without discussing the wonderful matplotlib. We can get rid of Seaborn, doesn't matter even if the thing requires us to do that, because if you know how to plot matplotlib, plotting in Seaborn shouldn't really be difficult. I'm gonna pause here, right? We've looked at quite a bit, but I wanted to find out if you have any specific questions about Python pandas, right? How we read data, how we select sections of data, how we filter out data, right? And stuff like that, right? How we inspect our data frame, right? I don't know if there are any thoughts or questions. Don't know if people can hear me, but can you hear me, colleagues?
Yes, we can hear you.
Yeah. I'm very glad that whoever was praying for the gods to give us more time here was doing the right thing here, because we were not going to be fair to you if we did not cover some of these things, because a lot of, this is a foundation, right? A lot of things that you're doing going forward. It's crazy here. A lot of things, they're going to assume that at least you know how to program in Python, right? And all those things. So I don't know if there are any specific questions, or maybe you will have questions once I share the notebook and stuff. I hope. All right, so this is 2024. If there are no questions, then we can I think we can leave it. We can leave it at that for now. We can leave it at that. I'll be in touch, especially after our postgraduate meeting tomorrow. And all that. I'm surprised that there are no questions, right? I'm sitting here and I'm wondering why there are no questions here. Maybe people already know this or something. Maybe not. Yes? No? By the way, I'm just trying to look at this is beautiful stuff. I'm looking at the things that are coming next term, right? You have machine learning is mandatory, right? So some of the things that I was supposed to introduce you to in scikit-learn, for instance, you're not doing machine learning, right? This is where you learn how to build inference models. The idea behind introducing you to the scikit-learn library for this particular course is so you'd be aware of how you use kind of like different attributes and methods and stuff from there. But whoever's going to be teaching you that course will probably introduce you to that. That's not a problem, right? So you'll be using Python, obviously, maybe a few other libraries, and then you'll have data visualization, which incidentally is going to be a detailed outline of how you use these visualization libraries like matplotlib and Seaborn, right? Where the remaining bit here is supposed to just gloss over. We have a sense of how we install matplotlib, how we use it to generate basic plots, and the idea behind what a plot is. That's it. How you work with aesthetics like titles and stuff like that, but I don't know if this is making sense. And then I think whoever was, sadly I was not a part of the design of the program, but whoever was doing this program, the people that were involved, really did their homework, right? If you look at what you're doing in year number 2, again, you're assuming you know how to do this, like there's NLP, right? Natural language processing. And then, you know, again, if you look at NLP, there are a series of libraries, NLTK, SPACY, GenSim, and all those things. So all of these assume you know how to program in Python and stuff, right? You know how to use a number of these libraries because they combine these like deep learning. Okay, colleagues, I see there are no questions. I think we can leave it at that. I want to pause here and just mention that for those of you that are writing the deferred assessment, please, you want to prepare one tentatively scheduled for Wednesday at 13 hours. 13 hours, so take time off, drive through Unza, you skip lunch or something, so we write this at lunchtime or something. All right. So with that being said, colleagues, thank you very much, and I'll see you when you see me, which is I think on Saturday or something, because we're supposed to tentatively have a test 2 on Monday, so we're eating into what was supposed to be our session on Monday. Thank you very much. And there's I don't know if there's comments in the chat or something, but before people leave, just in case there's an important question here that somebody wanted to ask, I don't know if I'll be able to. Oh, this is not. Oh no, it's not. Record the class. Yeah, I was recording this. I'll share the recording. Yes, is that a hand up? No. Yes, there's a question from Ms. Sarah.
The deferred test is on which Wednesday? This coming Wednesday or next week?
I would actually prefer that we write it this Wednesday, but if there's a concern, I only know of one person who applied for a deferred assessment because they were unavailable. Ideally, I was supposed to admit it today at 13, but they told me that they would only be back in the country today, so which is why I'm scheduling it for Wednesday, this coming Wednesday. But if the people that applied for a deferred assessment are not available this coming Wednesday, let me know. It's important that you let me know. And to attempt to try and avoid a situation where we're inconveniencing people that are prepared for this deferred, it's just 1 or 2 people will still proceed with the deferred, and then we'll have a deferred for the deferred test or something. So it's this coming Wednesday, tentative, like 13 hours. I will send mail and a comment as well on the WhatsApp group. Okay. Does that answer your question?
Yes, it does. Thank you.
Yeah. Colleagues, thank you very much. And like I said, if you joined us late, a reminder that these exams were scheduled to take place between May 11th and May 22nd. So it's a 2-week period. The draft timetable is not yet out. We have a meeting tomorrow. It's a school postgraduate committee where I anticipate we will probably be availed the draft timetable. But if I were you, I would apply for local leave or something, whatever it's called at work. You take time off during that exam period so that you at least prepare for the exam and you're not inconvenienced. Because if you don't write that exam, right, you will write a deferred exam. And this deferred exam, if you look at the session dates, is only going to be written together with the exams you will have in term 2. So, so you don't want to inconvenience yourself like that. If I were you, but of course there's certain things that are outside our control, like we get sick, funerals and all those things, agent work commitments. If that happens, if you anticipate you will not be available for the final exam, it's not like the test where you can just randomly schedule for a deferred assessment, right? You have got to formally write to the assistant dean to say you're applying for a deferred assessment, not to me, but to the assistant dean. You're applying for a deferred exam for whatever reason or something. They always say yes. They only complicate matters if you don't formally write and then you just suddenly show up right after the fact. Anyways, thank you very much. I don't know. Thank you very much and see you on maybe Saturday or something. Good evening. Bye.
Bye.
Good night.